Hi students, today we are discussing about virtual memory. So in the sense, what is virtual memory? So virtual memory in the sense, when a process is executing, it will be compulsory stored in an main memory. It will be compulsory stored in an main memory. So on that time only it can be executing. Okay. So when the problem is occurs, when process is consisting of an 10 GB process consisting of an 10 GB of memory, and my main memory is consisting of an 4 GB. Okay. So process is consisting of an 10 GB and main memory consisting of an 4 GB. On that time problem will be occur because of process is 10 GB and main memory is an 4 GB. It will be not executing in an main memory. Okay, the process cannot be stored in an main memory. On that time the process can be stored in an secondary memory. So it is called as an virtual memory. Okay, now so virtual memory is bigger than the physical memory or main memory. Okay, so the virtual memory is an bigger than the physical memory and main memory. So this is the diagram showing for virtual memory that is larger than the physical memory. Okay, so next virtual address space. In previous classes in first unit we are discussing about process diagram. Okay, in the process diagram we are consisting of an code, data, heap and stack. Code is used for storing of an text variables and code segment. Codes సంబంధించిన information can be stored. Okay, and next data can be used for storing of an local and data can be used for global and statical variables. Global variables and can be storing on a statical variables. And heap is used for an dynamic memory allocation, and stack is used for an storing the local variables. And heap and stack are always in an opposite directions. Always it will be an opposite directions. It will be using of an this free space. Heap and stack will be consisting in opposite directions, and it will be using of a this free space. And the main concept is an demand paging. Okay, so what is an demand paging? The basic idea behind the demand paging is that when process is swapped in, okay, when process is swapped in, its pages are swapped in all at once, rather they are swapped in only when the process need them. Okay, so demand paging in the sense, when process is storing in an secondary memory. Okay, because it will be not enough for an storing in an main memory. When we are discussing about swapping concept too, the process will be storing in an secondary memory, it will be come to an main memory, it is called as an swap in. And the process, it can be stored in an main memory, it can be going to an virtual secondary memory, it is called as an swap out. The program A is executing. Okay, the program A is executing. The pages which are stored in an A regarding to the program A, it can be stored in an A secondary memory. It can be come into an A main memory, it is called as an A swapped in. After completion of an A program A, okay, after completion of an A program A, the pages which are going to an A virtual memory. Okay, so why these pages are swapped in and swapped out in the sense, when the process will be an executing, the process which are needed of the pages, it will be an swapped into an main memory. ఓకేనా, సో ప్రాసెస్ ఎప్పుడైతే వాటి యొక్క పేజెస్తో అవసరం ఉంటుందో అవి ఎప్పుడు ఏమవుతున్నాయి, వాటి మెయిన్ మెమరీలోకి ఇన్ అవుతున్నాయి. ఓకే, సో దీన్ని ఏమంటున్నాం, స్వాప్ ఇన్ అంటున్నాం. సో ఎందుకోసం ఇన్ అవుతున్నాయి అంటే ఆ పేజెస్ ఏ పేజెస్ అయితే అవసరం ఉంటాయో ఆ పేజెస్ని మాత్రమే ఇన్ చేసుకుంటుంది. ఓకే, it is called as an swap in. Okay, so demand paging in the sense, when the pages will are required, pages ఎప్పుడైతే రిక్వైర్ అవుతున్నాయో on that time only the pages are swapped into an main memory from virtual memory. Okay, it is called as an demand paging. When the pages are required for process, it will be an swapped in from virtual memory to main memory. It is called as an demand paging. So next, in demand paging, page table when some pages are not in a main memory. So we are discussing about paging concept. In paging concept we are discussing about page table. So what is a page table? So what is paging? Before discussing about page table, what is paging? So paging in the sense, the main memory can be divided into a number of frames, number of pages. The main memory can be divided into a number of pages, and CPU will be providing of an a logical address. Okay, so logical address it will be consisting of an a frames. This is the logical address. It will be consisting of an a frames. Total 7 frames are there. Okay, so if these 7 frames are stored in an a pages. Okay, so each and every frame it can be stored in any places of an a pages. So what is the use of page table? In the sense, the page table will be describing of which type of frames are stored in an which pages. Okay, what are the frames are stored in an which page? Suppose I will consisting of an 8th page, so A is an one frame. Okay, so it can be stored in an 0th frame. 0 frame can be stored in an 4th page. Okay, it will be displaying of an 4th page. 4th page it can be stored in an A అనేటువంటి ఫ్రేమ్ అనేది 4th పేజ్లో స్టోర్ అయింది. సో ఇట్ కెన్ బి డిస్క్రైబ్ యాజ్ అన్ వ్యాలిడ్. ఓకే, సో అదర్వైజ్ దర్ ఈజ్ ఏ నో పేజ్ ఇన్ అన్ మెయిన్ మెమరీ. మెయిన్ మెమరీలో ఇట్ కెన్ బి నాట్ కన్సిస్టింగ్ ఆఫ్ అన్ ఎనీ పేజ్. ఇట్ కెన్ బి డిస్క్రైబింగ్ యాజ్ అన్ ఇన్వాలిడ్. I is can describe as an invalid. So here in main memory I consisting of an ACF. ACF are the only 3 pages are described. So in page number 4 it will be an 0th frame. 0th frame consisting of an A, and page number 6 it will be consisting of an 2th frame. 2th frame is second frame is an C. And next in page number 9 it will be consisting of an 5th frame. 5th frame consisting of an F. So ACF are only stored in an main memory. The remaining and all the frames are stored in an virtual memory. Okay, so when the main memory it will be not consisting of any pages, it will be describing as an invalid. If the pages are performed in an main memory, it can be describing as an valid. So this is about the page table when some pages are not in an main memory. And next concept is an phase fault. When was the phase fault will occur? So what is an phase fault? Phase fault in the sense, when the page will be required, on that time the page is not consisting in any main memory, it is called as an phase fault. Okay, so when the page will be required, CPU is executing that page, but that page is not in an main memory, so it is called as an page fault. So when the steps to handling in an page fault, so first step, load M. Okay, so mth page, M page is an we have to load by the CPU. Okay, so first it will be checking an page table. So page table it is an invalid, because invalid in the sense the page is not performed in an main memory, it will be not consisting in an main memory. So it will be going to an operating system. The second step is trap to operating system. So operating system will be checking of an page is having in an secondary memory. So in the secondary memory it will be checking the page will be having or not. If will be possible, so it will be it will be loading into an main memory. It will be bring into an main memory. Missing page it will be loading into an main memory. After that main memory will be reset the page table. So it is will be invalid become to an valid, and it will be restart the instructions. So it will be page will be available. So this concept is called as an phase fault. When the phase fault will be occur, so when the CPU will be loading, CPU will be executing any pages, it will be not performing in an main memory, it will be not there in an main memory. On that time only page fault will be occur. And next concept is an performance of demand paging. So demand paging will be performing in the based on some formula. It is called as an EMAT. EMAT in the sense effective memory access time. Effective memory access time. The formula is P of page fault service time plus 1 minus P into main memory time in nanoseconds. Main memory access time in nanoseconds. So I have consisting of an memory access required is an 200 nanoseconds. So formula is EMAT. EMAT in the sense effective memory access time. Okay, so it is an P P into page fault service time plus 1 minus memory access time into nanoseconds. So page fault is an 8 milliseconds, and memory access service is an 200 nanoseconds. So I have to apply this time into this formula. So it is 1 minus P into memory access time is 200 plus P into page fault service time. It is 8 milliseconds, so it will be converted into nanoseconds. It is 8 lakh nanoseconds. So calculate this. 200 plus 7 lakh 99,900 800 into